Does that mean we're live now?
Yes, that means we're
Yeah.
live.
Crazy. A cast of thousands.
All right. Let's yield the floor to John.
Okay.
Yep.
Yeah, cool. So yeah, today we have the gRPC team on, which is amazing. I want to give you plenty of time. I'll let you introduce yourself when you start talking. Let me jump in with the community links at the beginning, and then we can switch over and you can do your thing. So let me find. There it is. Cool. There it is. Okay, so I'll run through these. We've got a lot of fun links today. First of all, Rick Strahl did a live reload middleware component. This one was really fun because I got to watch it kind of happen on Twitter and stuff. He had some great feedback. So the idea here is it's middleware that as you edit your site, the middleware is running using .NET Watch Run. And, he shows here updating things in the site, updating CSS, etc. And, it's updating on the site. So he worked through, first of all, creating standard middleware and just refreshing the entire, like using a file watcher and just injecting JavaScript and reloading the HTML. What he found here was David Fowler got back to him and said, "You're allocating like crazy." And so this was really cool to kind of watch as he updated and looked at ways where he actually wrapped the response stream, used some of the advanced, kind of memory buffers and span, and looked at how to make it reload faster. So this kind of goes all the way through and shows his kind of completed implementation of it. Also, then towards the end, there's some caveats here. There's questions about, making it work with HTTP2. There was also a question about Blazor. Will this work with Blazor and how to make that work there? So a lot of great stuff here. Number one, this looks like really useful middleware. And then number two, we all learned a lot looking at the stuff he found out with David's feedback on allocation. This is a recent on.NET show. This was an interview Shane did with the team here, so Glenn and Ryan, and talking through some great stuff. So mention of gRPC, which we're going to learn some more about today. Also talking about the work. Oh, were you on there too? Okay. The worker template, and then kind of wrapping up towards the end with how do you choose between gRPC and Web API. So good stuff. Shahed's continuing. I believe this is number 22 of 26 for his series he's doing. By the way, he's also going to be packaging these up as a book, which is really cool. So this has been fun to see. All kinds of stuff in this, V for validation. So talking about validation attributes, server and client. One neat thing that he did too here I like is he talks about remote validation. So this is looking at client to server for things like if you want to go through and say order tickets and you need to validate from the client before, showing actually are there, tickets or products or whatever in stock. So showing how to do that. So a lot of great stuff, and I'm excited to see that book. Cool. So DoDG here. Here, this is the updates. So I'm just pointing this out. We've mentioned this one before, but here he's updated up through 250 samples now, and this includes 3.0 Preview 5. So this is a great resource for all kinds of stuff. And again, the way he breaks these down, very kind of bite-sized implementations. So most of these you'll look and they'll be just very targeted, and they'll show just one feature at a time, which is really useful. Lee here going into ASP.NET boilerplate. So we've talked about ASP.NET boilerplate in the past. Here Lee has an over an hour video showing off just different features here, and so he just kind of steps through and creates things. Here he's using an Angular site, and he just shows kind of how to set that up. So good stuff. Ken with what's new in Azure SignalR service. Some neat stuff here, including endpoint routing, which is cool to see that. So, digging through and showing the example of how now you can set up using the using endpoint routing and how that simplifies the code.
So gRPC also uses endpoint routing.
Cool.
It's a great way for us to provide routing, and anyone can write a framework and quite easily plug into it.
Cool. Thanks, James. So that has been really cool to see over time. And the first implementation, I believe, with 2.2 was just turning it on for MVC, and so now endpoint routing lighting up with SignalR and gRPC, and it just kind of available everywhere for routing is really nice. Cool. Awesome. Okay, so here, speaking of gRPC, this is from Chris, and he's writing about using gRPC services with server-side Blazor. So I like here the idea of looking at two new features and kind of tying them together. So here's explaining gRPC, getting it set up, creating a gRPC service, and then he also creates a client, which is a server-side Blazor client, and then calls over to it. So sometimes I'll find this is a place where when I try and hook two new features up, the two features work in isolation, but the two of them together, sometimes you run into problems. Looks like here this actually worked pretty smoothly for him, so that's cool.
So just speaking to that about like hooking up multiple new features, if folks haven't seen it, I think you might have mentioned before, Dan's docket build was fantastic. It hooked together Blazor, the new service workers, gRPC. If you want to see all our new stuff work together, I'd highly recommend go look at Dan's talk from Build.
Cool. Yeah, that's, Dan's talk, everyone loved Dan's talk, and it was a really, really, really smooth talk. That was 3 reallys there, where he kind of integrated a lot of different stuff and showed everything working together smoothly. And I feel like that also kind of showed the value of like, here's how all these pieces fit together to build a really nice application. So, yep. Okay, this is cool. Code stencil. So AO actually contacted me separately about this, and when we wrap up the community links, he's actually giving away 2 licenses for free to people that are watching the show. So I will put the link in the chat right as soon as I wrap up the community links, and I'm not sure if it's the first 2 responses or if it's a random drawing, but you can enter there for free license. So what's neat with this is a code generator. It's going through and it will look at your database and generate code based on it. Sometimes code generators are pretty verbose. From looking through the actual tutorials today, I was pretty happy to see kind of the balance of it, that it does generate model classes and those sorts of things based on your database tables, but and also your views. But then there were other things, for instance, like the navigation, where it was pulling those, it was creating that dynamically. So so pretty cool. And this specific post is talking about the Razor stencil. So this is Razor pages generated from your database. So, and again, watch for the end of the, right when I wrap up these links, I'll be putting that in the YouTube and Twitch chats for people to get in on that free giveaway. All right, Bill writing about augmenting the I principle when using identity server authentication middleware in ASP.NET Core. So he's got, he's using the authentication middleware. He wants to augment the principle to add additional information to it. And he found out he ran into a problem which was that things were overwritten at the end of after the authentication. I like this animated GIF here that he's got, by the way. So at the completion of the authentication, then it was his values were overwritten. You can see that here, the property was null. So this was one of those where actually going into the comments, there were some useful information here. So, Dominic, who helps run or is one of the 2 authors on Identity Server, said, well, you could, create a PR, et cetera. And Khalid, who's on the same team at RimDev, said, they're on Identity Server 3 at this point. Another nice thing here is Thomas is saying you could use an I claims transformation. And so Bill actually goes through and shows, here's some sample code to do that. There's some small things that you lose as far as control there, but overall, this seems like for most cases, this would probably handle things there. All right. This is a cool, just kind of quick one here. If you want to start using ASP.NET Core 3 Preview in App Service, reminder that you can go through, first of all, you'll hit an error because it's not deployed on App Service yet, but you can do a framework-dependent deployment. So just as part of Publish, you can set deployment mode to self-contained, set your runtime, and you're off to the races.
So I just want to point out one gotcha, because I see a lot of people run into it. When you do self-contained, make sure you pick the right bitness, because App Service defaults to 32-bit apps unless you go into the portal and change that. That's been, I think it's highlighted in that screenshot that's on your screen right now.
It's here, but they need to match.
Yeah, so that's a common pitfall we've seen people run into. And if I think you just scroll past it. The tooling in Visual Studio also prompts you, like when you try to publish, that the runtime doesn't exist in App Service just yet. So that's, you know, we're trying to catch you, make sure you don't fall through the cracks and end up in a failure case. But
Good. So the point there is that before even going out to deploy, it's going to say, hey, wait a minute, you're trying to deploy in a runtime that's not yet.
And if you go a little further up, you have this. So we've had, you know, the generic 500.0 error page, which is rendered by the ASP.NET Core module. There's some fun stuff coming there. I can probably talk to it in like a future episode, but we're doing a lot more to handle startup error failures. So we log a lot more to the event log when possible. We show details in the browser. So all this stuff is coming in 3.0, and you should look forward to that.
Very cool. All right. I'll try and hurry through because I want to see all your great stuff. Here's a quick thing. Here's just a tweet. This will be shared in our show links, but Damien mentioned that the team is doing some basic compat testing for NuGet packages with ASP.NET Core 3. So this is, if you want to vote, if you want to say, hey, here's something that's important to me, I would like you to include in testing. Want to make sure people saw that. All right, this is fun. Meher has wanted to look at taking a Blazor app and hooking up with Electron.net. So Electron.net to create a desktop application. So Electron.net has support for a global tool. So there's you do .NET tool install Electron.net CLI, a init on the application, make some small changes, and then to run it, you just did electronize start. And here, it's a little hard to see, but this is actually a full application here. So just kind of neat. I know there's already been that prototype. I think Blectron was the name, and that was one that the team had done early on. This is using electronize.net, which is neat, or electron.net. All right. Scott Allen here is talking about how do you, if you need to know at runtime if an authorization policy will succeed. So say, for instance, if you want to update your menus on a page and only show, like, say, admin links to somebody that would be authenticated as admin. And especially if an authorization policy is running some logic, you know, here he's got just a very simple random number one, but let's say you needed to do something more in depth. So fortunately, you can just inject the authorization service, and then you can say authorization.authorizeUser, and that'll let you know whether or not, in this case, whether the user is lucky, but more importantly, whether or not the authorization would succeed. So this is nice to know whether you can, you can modify your page layout, you can modify what you're displaying to user based on whether they could pass an authorization policy. And finally, wrapping up here, we've been sharing these weekly links using different, one tab, and we've used some other things in the past. So Burke Holland and Cecil Phillip both saw that, we've got some kind of halfway solutions. They actually created URL list, and they did it. They said they had our show, the .NET Community Stand-Up, in mind when they were doing this. So this is a neat walkthrough that they do where they're using they're doing things serverless as much as possible. So things are done using Azure Functions. They're writing stuff out to blob storage, Cosmos DB. They have a Vue and TypeScript front end. And the end result is that you can go through and create a collection. So you can do this now. You go to the urllist.com and you can create something. So in depth here, they walk through everything. How they built it. It's out on GitHub if you would like to get involved. And here are our community links for the week. So it worked out just great for me. I had some feature requests because, of course, you do that. But here's all our community links for the week. I'll be sharing these in the show chat, and you can go through. And also, I recommend that you play with the URL list. And with that, I'm going to stop talking, and I'm going to pass back over to you folks.
Okay.
All right, so we got the gRPC team. Do you want to introduce yourselves?
All right, I guess I'll go first. My name is John. I am a dev on the ASP.NET Core team, and I've been working along my friends here on the gRPC support from ASP.NET Core. And we've been doing that for the past several months. So now we're going to showcase what we have.
Hey folks, my name is Saurabh Shirhati. I'm a program manager on the ASP.NET team, and I've been working with John and the rest of the folks here.
And James.
You want to switch to the Teams view so people can just see faces?
Let's see if James can.
Hi,
show his face.
my name's James Newton King. I'm also a dev on ASP.NET team, and yeah, John and I have been working together with the gRPC team at the Cloud Native Computing Foundation to bring gRPC to .NET Core. And from the CNCF team is Jan, who's on the call with us.
Hey, so I'm Jan. I'm a member of the gRPC team at Google, actually. And I've been on the gRPC team since gRPC's early beginnings, which is, I think, like 4 years ago now. And I'm the owner of the original gRPC C# implementation.
Cool. So to start with, I'm going to share my screen. Can someone handle switching to it?
Yes, I
it's showing
believe we
up
can
great.
see your slides.
Okay, great. So to start with, we'll just do a quick little slideshow to sort of introduce gRPC to a lot of .NET developers. It's something which I don't think there's been a huge amount of mindshare around in the .NET space, but gRPC, it's a remoting RPC framework that's caught on quite well, and as far as we can tell, has the largest mindshare out of RPC frameworks. Like, there are some alternatives out there, such as Apache Thrift. gRPC comes from the Cloud Native Computing Foundation, and gRPC, it's actually a recursive acronym. So if anyone asks you what it stands for, it actually stands for gRPC Remote Procedure Calls. gRPC is built with modern technologies, so it's a relatively modern RPC framework. It was sort of open sourced around 2015, and it uses HTTP2 for the transport, and uses various HTTP2 features such as streaming, and it also uses protocol buffers in a number of different ways. Although protobuf is usually quite closely associated with gRPC, you can use other formats for sending messages through it, but we'll just be focusing on protobuf today for simplicity. And gRPC, it's designed for modern apps. It has quite good support throughout all its libraries for built-in tracing and logging, and also technologies like deadlines and cancellations to ensure that your overall application infrastructure doesn't have a runaway process that consumes lots of resources. So protocol buffers, it actually serves three purposes with gRPC. So the first is an interface definition language. So we can see here an example of a protobuf file, and we're defining a couple of messages and then a service called topics, and then it has a subscribe method on it, which takes a request, and this particular method is a streaming one, which will stream from the server to a client, and it will stream multiple event objects. Protobuf also serves as a service model, so generally code generation will run over the top of this protobuf file and then generate your service CS file, a client for your gRPC service, and also messages. And then finally, protobuf acts as a wire format. So when you send messages between the client and the server, your message will be encoded in protobuf, which is a very efficient binary format.
So actually, James, I've seen some questions from the community about protocol buffers, and one of them is actually when you use gRPC and you want to use something else other than protocol buffers, how would you go about doing that?
Today, there's many different frameworks for gRPC, so obviously it will depend on what framework you're using. With the one that we are developing, there are some ways to hook into the serialization methods. It is possible. I don't think we'll have time to go into it in detail now, but it is something we would probably like to support people to be able to extend doing that and inserting their own serialization formats, but it probably won't be like our focus. Our focus will be on delivering a good protobuf experience first, and then more extensibility in the future.
But to that point, I believe there's a community project for gRPC.net that uses MessageBack. So there are people who are living life on the edge who are trying these things out. We won't get to it for the foreseeable future.
Yeah, and a lot of the works that we're doing in terms of like optimization will also be more geared towards protocol buffers, and that will be our first class experience, and then we will potentially look into other extensibility later.
So a key benefit of gRPC versus HTTP1 and REST and JSON is its performance. One way it achieves that is through a low network usage. So HTTP2, it's a binary protocol compared to HTTP1. It supports header compression. So header compression becomes really useful when you're sending commonly occurring headers. So for example, if every gRPC request has the same content type, we can use header compression to convert that from some UTF-8 text down to just a couple of bits compared to HTTP1. And also protobuf, it's a binary serialization format, and it's very efficient compared to JSON. So if we compare a JSON message versus a protobuf definition, so this isn't an apples to apples comparison, because if I was actually showing the protobuf message, it would be just some random characters or maybe some base64 encoded text. But we can see here on the left JSON message. Some things to notice about it is it includes the property name for every single property. So there's some size there, and also it's self-describing. So we need to double quote things to indicate they're strings. We need to have open and closed brackets. We need to have semicolons to delimit everything. Protobuf, it's a binary format which relies on you having the definition to be able to make sense of it, which has some cons, but one of the very big pros is it's extremely efficient. So if we compare the two, we can see that protobuf is probably a third the size to a quarter the size of JSON. The difference would shrink if you were using gzip. It might only be maybe half the size, but a protobuf message will always be smaller than an equivalent JSON message.
Yeah, one thing I would add is also, it's also much more efficient to parse and to serialize.
Yeah, that's a good point. The binary format that it has lends itself quite well to efficient serialization compared to comparing characters in JSON.
So one of the questions, sorry James, just to interrupt, we got a question on Twitch saying, can you use this in .NET Core 2.2 or is it dependent on features in 3.0?
And
so what we are making will be dependent on 3.0. There is a different gRPC framework, the existing one, which you might see on the gRPC website. I believe that will work with 2.2.
And I think one thing we can just, clarify terminology so we can disambiguate. When we use the term gRPC core, which we will use multiple times later today, we're talking about the existing implementation, which is based on gRPC's existing C core implementation. The new stuff that we're doing is based on our own networking stack. So gRPC, the C core based version, will work with 2.2. The version that's based on Castrol and HTTP client will not work with 2.2.
Yep, perfectly answered. So another benefit of HTTP2 is multiplexing. So we can send multiple calls via a single TCP connection. So this is a comparison I recorded on my computer of a image which was split up into 200 smaller images, and you can quite easily see the quite enormous performance improvement by being able to use multiplexing. Another key feature of gRPC is code generation. So code generation is at the core of gRPC, and it's driven by the protobuf IDL. Given our protobuf file that we had before, we had our messages and then our service with our method. What we would do is include that protobuf file in the CS proj. So it's, if you can see my cursor, it's this protobuf line here. We just include the file. We say what we want to generate. In this case, we want to generate a server stub. But you can also say you want to generate the client or maybe both. And then the compiler will automatically invoke the code generator and generate a service stub and messages from this protobuf file. So this is a very, very simplified view of what you would see for the service stub. So we've got our method, which takes a single request. It streams a response of events, and then it has a server call context, which is kind of similar to an HTTP context in .NET. And then you would take this class, you would override this method, and then you would hook it up in your startup file. It also would generate a client. So this is a strongly typed client, which would handle serialization and building the correct URL for you. Another key feature is streaming. So
James,
gRPC.
Just to interrupt, we got another question coming in on Twitch, which is, is there mobile support for HTTP2, and can they use it from mobile devices?
Yes, you can. So I believe what we're writing should using HTTP client. So we're going to talk about the client, obviously, because it wouldn't make a huge amount of sense to host the server on a mobile device. But we're we're creating a client which uses a gRPC client, which uses HTTP client internally, and I believe that should work on mobile devices in Xamarin. I know the C-Core client does. Is that right, Jan?
Yes. Well, it's been used by some users. We still call it like experimental support because we don't claim it's like fully supported. But I've heard from users that have been using that successfully on Xamarin.
Okay.
And to that end, if you don't want to use Xamarin, you can still generate clients for, I think, Objective-C and Android are both supported. So you're free to use whatever ecosystem you already use on your mobile devices and still talk to a gRPC server which is using .NET, or for that matter, any gRPC server.
Yeah. So streaming is another key feature of gRPC. So gRPC utilizes HTTP2 to enable streaming, and there are different method types in gRPC. So we have a simple unary call. So a client sends a request and a server sends a response. So this is what most people will be familiar with in HTTP1. We have server streaming. So this is what our code sample before showed. We'd send a single request. The server could then send multiple responses. Client streaming, which is just the reverse. And bidirectional streaming. So a bidirectional stream, the client would establish the connection with the server, and then they can independently send messages to each other via that TCP connection. Another key feature is what we just talked about now, multiple languages. So there are many implementations of gRPC, both server and client, and these are all organized and developed by the Cloud Native Computing Foundation. And there are a common set of interop tests, which all of these implementations follow, including the one which we're writing to make sure that they can talk to one another. So you're probably thinking, wow, gRPC is great. Let's throw REST and JSON in a dustbin and live in gRPC land forever. There are some disadvantages with gRPC. So one is browsers have great HTTP2 support. Unfortunately, JavaScript APIs inside the browser haven't caught up. So XML HTTP request and fetch, which is what you would commonly use in JavaScript to talk to a web server, don't provide low-level access to HTTP2 frames. And because of that, it's not possible to write a proper gRPC client in the browser. There is a workaround. So there's a technology called gRPC Web, and it provides limited support for calling gRPC services from a browser. So this is developed by the gRPC team, and the way it works is there is a proxy which sits in between your gRPC services and your web browser. So the web browser would use the gRPC web client, which can talk either HTTP1 or 2, and then the proxy would then translate that call into a real gRPC call and then forward it on to a gRPC service. So there are some downsides to that. For example, if you're using gRPC Web, you don't get bidirectional streaming support. And I think maybe client streaming is slightly spotty as well. Another disadvantage is it's not human readable compared to HTTP1 and JSON, both of which are text formats. So you require additional tooling or additional steps to be able to debug gRPC calls. So for example, I have Wireshark open here, and I'm looking at a TCP packet for HTTP2. But the tool was able to recognize that it is a gRPC call, and I'm able to view some data about the gRPC call. In this case, I can see they're calling a greeter service and a say hello method, and this is the response. And then I can view the response down here, and you can see some UTF-8 text shows up, but for most case it is not easy to understand. Now there are ways to improve this. So we talked earlier about using JSON rather than protobuf in our messages. So one strategy is to use JSON when you're developing on your local computer or in a test environment, and then switch to using protobuf in production to get the performance benefits.
Yeah, I would actually stress the part where, so it's all about tooling, and because gRPC, is getting a lot of traction with the community, the expectation is like over time there's going to be more and more tooling. So we're hoping that this is going to be, less of a problem in the future. Because like if you have like all these tooling that already have like built-in gRPC support, for example, like Wireshark plugins and stuff like that, you'll basically be using, gRPC as if you were using JSON, because the tooling would provide you that support.
Mm.
So James,
okay,
we got a fun question on Twitch for you. Question is WS HTTP binding going to be supported in gRPC?
You could write a proxy.
I think maybe the fair thing to say here is like the transport is pluggable. You could do it if you're adventurous. There's nothing first class for it now or for the foreseeable future.
Yep. We're focusing on HTTP2 and protobuf. So those are the commonly used ways of communicating using gRPC, but we're always open to providing like APIs for people to maybe extend it, and if you have ideas like that, create an issue on GitHub. We should show the GitHub repository at some point, and we can talk about it. Okay, this is the last slide. So this is what are we doing in .NET Core 3.0 for gRPC. So we have some existing packages. These white packages are the currently published on NuGet, and these are the C core implementation of gRPC. So gRPC.core has a native server and native client. Those wrap binaries which come in the NuGet package, and then Google.protobuf is the serialization handler for protobuf. And then we're shipping in 6. So already we're shipping gRPC.ASP.NET Core.Server. So that's our server implementation of gRPC. It's hosted on Kestrel, and it's able to integrate with the rest of your ASP.NET Core ecosystem. So you can interop with middleware authorization, middleware routing, and so on. And then gRPC.NET Core.HTTP client, that's a managed client we're going to be shipping in Preview 6, and that uses HTTP client and its new HTTP2 support for a gRPC2 client.
Actually, I think this diagram is a little bit out of date, because we have decided to split some of these packages into more packages. For example, the client has been renamed to gRPC.net.client, and then we're adding other integration support for essentially client factories and integrating that into we also have server-side integration for that as well. and that comes in gRPC.ASP.NET
Client factory.
factory. So there are quite a lot of different packages, and we to simplify that, we will be looking to add a meta package so we can essentially make it easier for people to reason about how to which packages are actually needed for the workload. And on the topic of essentially packaging and what we're releasing, let me just address a few of the questions I see also on YouTube and Twitch, one of which was essentially support for tooling, for example, the protobuf item that was demonstrated in a few of the previous samples. So the support for tooling, it actually comes from the gRPC.tools, mostly comes from gRPC.tools package that includes the Proto-C, essentially the protobuf compiler, and a lot of the plugins in there, as well as the MS Build integration. And that is already currently available. So essentially, if you're on 2.2 already, you can use that if you are not looking to run on the Kestrel server. So that is currently already available. We are also contributing to that to make it better for 3.0 as well. So we will have updates in that area. And then there were, for the tooling side, most of the support comes from gRPC.tools, and that's currently available. So I just want to address that question.
Just a question, James, was that your last slide? Because there are a couple of questions that have accumulated. This would be a good time to, good segue to try and address those.
Yeah, that's it.
Okay. All right, so let's see.
So another thing that has been brought up in the YouTube chat is, you said that gRPC doesn't work very well in browsers because of limitations in support with especially JavaScript. How does that affect something like, for example, Blazor? Does it suffer the same limitations? How are we working?
So the limitation was you don't have access to HTTP2 framing from browser APIs like XHR and Fetch. Blazor doesn't use that. Blazor uses either WebSocket, like Blazor negotiates, but it uses WebSockets, or it can fall back to, SSE and things like that. So we don't have this limitation in Blazor.
I'm not sure. Like server-side Blazor, there's certainly not this limitation. I'm not sure about client-side Blazor.
So the limitation would be if, for example, in future we wanted to support a HTTP2 transport in SignalR, then we couldn't do that. But the way Blazor works today, because it uses WebSockets, we don't have that limitation, right?
I don't know. I don't know how client-side Blazor does its HTTP requests. Like if someone creates HTTP client and creates a call inside client-side Blazor, is it using some sort of .NET
It's my understanding
networking
that
stack, or is it
we
using the browser stack?
So I could be wrong. It's my understanding that it uses the browser stack, and we use Fetch, and if Fetch isn't available, we polyfill.
Right.
So
agreed. Yep.
Yeah, just to give a little bit more background on why gRPC protocol wouldn't work well with the browser API is that gRPC, like the protocol definition, uses HTTP2 trailers, and that's not exposed in the browser API. So you're basically not able to return back the status of an RPC, which obviously is a problem. So unless you're using those parts of HTTP2 spec, you won't have a problem.
And another couple of other questions I want to address. One of which is essentially, how does gRPC compare with SignalR and something like Socket.io? So I guess for the first portion is that gRPC is a much lighter weight RPC framework. And yes, there's similarities with SignalR. For example, there is streaming both directions, and then they're very similar, kind of like RPC like frameworks, but gRPC is based on code gen. It is design first, and by that I mean you write a definition file, the protocol buffers descriptions, and then that gets code generated into C# or whichever other language that you are working with, and then that is essentially the contract. Whereas for SignalR, it's a little bit different in terms of that it's you write the C# code first, so it's code first.
A major difference is SignalR will keep track of all the connections. So with SignalR, when you connect to a hub, that hub will then keep track of that connection, and then additional people who connect to that hub can then do things like, say, send a message to everyone else connected to this hub but me, or send a message to all the people in these groups. gRPC on the server doesn't have this state. So each connection to the server, there's no giant pool of connections that you're able to easily observe and then broadcast out to all of them. It's much more similar to a regular REST connection where like you can't easily observe all the other people who happen to be making REST API calls and broadcast to them.
Mm-hmm. So I think we're seeing a bunch of questions on like SignalR versus gRPC. I think maybe we should like take a break from answering questions, actually jump into some code, show some bits we have, and let people see the app model, because you'll notice that some things are just easier to do, especially like browser interactions. The app model in SignalR lends itself well to that. It's not something you'd necessarily even want to do with gRPC, even if you could. So I think let's do that. Let's jump into some code.
All right.
See what gRPC actually looks like, what we're shipping today, what's coming up, and then we can come back to questions, because I don't want to not show off cool bits.
Sure.
Yeah,
Right.
yeah, that sounds good.
Let's switch to our demos.
All right. So we've been shipping gRPC for about 3 previews now, I think, starting from preview 4 or 5. So what we do ship is we have a template that ships in the box in Visual Studio. So if folks haven't seen it before, let me just
You want to create an ASP web application, right?
thank you, John.
Yeah.
And sorry, folks.
Are you? Oh, it's
okay.
back. Okay.
Looks like, yeah. All right. So let's go through with this, and so we have a gRPC service template. This will generate just the server-side code. It's been available since preview 5, so you can go ahead, get started. I'm gonna back out of this menu because I already created a project and I added a bunch of extra stuff to show you folks. But if
Which I think you just closed.
Oh, did I? Oh, my
Did
bad.
you close?
You're right, I did. It's okay, no worries. Start VS, right? Okay.
Yep.
So let me go ahead and open that project again. And so when you create the project, you get a solution with a single project. It's a server-side project. By default, we throw in one proto file. So this is similar to what James had shown earlier. This is what a protobuf file looks like. It's its own DSL. Here's my package name. Here's my service definition. Here are my actual endpoints. So in my case, this is a unary call. It's a single request, single response semantic, and these are my message definitions. So the flow that you would do is you would make all your edits here. For example, if I had to define another RPC, I could go ahead and do that. Let me just change this name so this doesn't conflict, right? And then we have code generation that's also already wired up, and what you would see get generated would be this database, right? So this is the generated code. It's wired up via design time build right now. But what you would end up implementing would be this would be your actual service definition. I can jump back to the proto file. Sorry, go ahead. John.
So if, for example, I was on older, I guess, using older bits or older packages or older tooling where design time build is not enabled, how would I run the code generation?
Right,
when
so,
would it happen?
So I think the point John's alluding to is the actual code generator that runs, that takes your protobuf file and generates the base class which you then need to implement. We've been working on tooling, so based on what bits you have, you might not have design time build, so you might have to trigger an explicit build. So I can trigger an explicit build just to show you what it looks like, and I'll go to VS and click on this show all files. Neat little thing that I never really use, but if we go to the generated code, you can see
it's a bit harder to see. Can you zoom in?
Oh yeah. Let's see. So this is really tricky with my trackpad, but I think we can do it. So you can see all this code was generated as part of the build, and then you'd go ahead and implement something like this, right? So in this example where I went ahead and added another service, if I go to my actual service definition, right? So if I want to now implement my new method, I can just go in here, override, and I have my new RPC that I can go ahead and implement. Just question: Is my font size okay? Can you guys see it?
It's I think it's fine.
Right.
Maybe a little bit small. If you can make it slightly bigger, that would be better.
All right.
And maybe make
It's fine.
It's fine.
It's
All
okay.
right. Okay, so what I've done here is so a couple of things I wanted to show off. Obviously, is this is recent as of Visual Studio, I think 16.1, where we have syntax highlighting for protobuf files. That's new. Go ahead and try it out, folks. If you run into any corner cases, go ahead, leave us some feedback via Visual Studio. We'll look into it. But so far, it's been out for one release. It's looking pretty good.
Yeah. And we also have a little bit more integration in terms of syntax errors, for example, in the protobuf files and stuff like that.
That's a fun thing to show, John. Okay, let's see. How do I mess this up? Okay, let me take a message that doesn't exist, and I go ahead and build.
And then look at your errors.
So we also have.
So you're validating against the
Right.
the protobuf definition.
And so we have the errors linked back to where they occurred in the protobuf file.
So it'll be easier to essentially find out where all your errors are.
So I like this flow, John. I think we should keep it this way. I keep doing stuff. You tell me what else to show.
Sure.
Well, one question from Tim. Tim Hewer's asking, he'd like to see a direct comparison. Maybe this is just overall feedback. Like to see a direct comparison between Web API, gRPC for ASP.NET Dev. So obviously you've pointed out the perf benefits, but what's the difference in dev in the developer experience?
Yep, that's a great idea, and we have a little bit of documentation on this. Essentially, our current documentation compares against REST, for example, but we can share the links for those.
Yeah, you can go and paste it into the chat.
I'll look into that. I'll let you continue with the demo.
Okay.
Yeah, and one other thing, just while I'm rudely interrupting here, Michael Powell's saying he thinks that the code generated should yield partial classes, especially for services, so that we can, extend them without having our code overwritten when you regenerate the code.
Yes, and the generated classes are partial, actually.
Oh, okay, cool.
So I can actually jump into that real quick. So yeah, the generated class is a partial class.
Ah, cool, cool.
So.
But I'm not sure why you would want to extend it using partial, because you would always want to inherit from the base class, because if we look at our greeter base at the moment, the virtual implementation of say hello would do nothing more than throw a not implemented exception. Oh yeah, an unimplemented status code. So you always need to inherit and override these method stubs. And these method stubs are useful because the Visual Studio tooling will just automatically do code completion for you, and everything's strongly typed. That's one of the benefits, in my opinion, of gRPC. The fact that code generation will handle generating your messages, it'll handle generating your base service, your client. So you don't have that overhead of first creating a service, then creating the messages, then having to copy and paste or maybe duplicate creating the messages on a client, then creating a client that's strongly typed and building up URLs and doing serialization. All that is handled for you in gRPC, and it provides a great end-to-end experience. All you need to do is just share these protobuf files between your project, or if you really don't like the idea of sharing protobuf files, you could even use code generation once in a shared service, have it target net standard 2.0, compile it, and then share that compiled NuGet package between your applications. So there are many different ways of doing it, and I think it's a really great benefit of gRPC if we're coming back to that earlier question about the development experience.
Yeah, speaking of that, there's a question from Twitch that I think I answered, but I'm not sure it's the best answer. So the question is, when I'm developing with REST, you can use Postman or whatever to validate things. When I'm developing against gRPC, I need a test client. And what I think is the answer is that you're developing that for me. You're generating a test client for me that I can use. Is that kind of the main thing, or should I use something else to do test generation?
There is a tool like Postman. I can't remember its name off the top of my head, but it is a GUI tool where you can ad hoc query gRPC services. Ad hoc querying gRPC services is going to be slightly more difficult because the protobuf file contains the definition of your message. So your first step will probably be loading the protobuf file into your ad hoc client and then making calls. But let me look it up, because I have seen someone talk about it, but I can't remember the name off the top of my head.
Right.
And also to that end, I think Jan can actually maybe speak to this. There is a CLI tool that you can use to as a client, I think, and I believe there's a canonical mapping between like text to how you do a representation of proto. So if you really need to like hack something quick and dirty, there is a command line tool that is available as part of the gRPC repo.
Cool.
Do you want to add anything to that, Jan?
Oh, no, I think you described that pretty well. Yeah, so there's a command line tool for protobuf. There's actually a canonical textual representation, and also with protocol buffers version 3, there's a canonical mapping between JSON and protocol buffer messages. So you can do basically like transformation one way or the other, and like it's going to be clear the way the mapping works.
So the tool I was thinking of, it's Bloom RPC. So it's open source. It's on GitHub. I just shared the link in YouTube. But it's a GUI tool around querying protobuf services, well, RPC services.
Okay, maybe we should continue with the demo.
Looks like.
Or, okay, I guess we can take a few more questions.
Yeah, it looks like I lost network for some reason.
Nice.
I think while I try to get this back, John, you can show the command line tooling experience that we've been working on. Why don't we switch over to your machine?
Sure. Let me try to
throw you right under the bus.
Let's see if I can get that to show up. Oh, I think this cable is actually just cursed, so I'll give it.
You
back
can switch
to you.
back to me, and then we can like physically switch over cables. Okay, so the thing that I was going to show off is, so I went ahead and added another proto file. We have, I think, John, we have shipped item templates for this. If you want to create a new service, you can use the item templates. It's part of the CLI now. We're going to add it to Visual Studio soon. So let me go back. So I went ahead and added a new, so I created a new file, right? described my service, described my messages, but then there's the point of actually adding it to my project so I know what code generator to set up. So this is fresh bits. I literally went over to the Visual Studio folks, copied some DLLs over from their computer and showed up here for this demo. So we have this connected services node in the Solution Explorer that you're used to seeing for projects. This is what we use for connected services when you connect to other Azure services. We have this node that we've introduced called service references. So if you go ahead and see, like, I actually have some stuff listed under the gRPC node. There's also the Open API stuff that I think we can do a future separate talk on, but it's going to be a very similar experience. So you can go ahead, click this. This allows you to either point to gRPC to an existing proto file. So, or there's also the URL based thing, and since I've already added it, I can click on the edit. The other thing you can do is you can specify options to the generator on whether you want to generate just a client, the server stub, both the client and the server, or nothing at all. You just want messages from that. So this UI that I'm showing you is still hot off the press. It's supposed to land in 16.2, and hopefully this will make you more productive. But you can go ahead and add this. The other thing you can also do is how do I increase this font size? I think this might be a better. So we have this tool. Is it .NET gRPC? John, can you speak to this?
Yes,
I don't actually know.
It's .NET gRPC, and then you can see the help text.
Okay.
So with this tool, we can manage essentially gRPC references. So you can add, for example, reference to a local protobuf file on disk. Also remote links to protobuf files via an URL. You can also refresh any existing references that are based on URLs, as well as remove references. So we've added that support. You can configure whether, again, similar to the VS tooling, you can configure whether this is for server or for client, for both. A couple of options there as well. And again, these tooling gestures will also ensure that if you, for example, specify a server service, then the necessary packages, the NuGet packages that are that contains those APIs will be added to your project essentially automatically.
Right, that's a good point that John mentions, because especially if you're using a client, it could be like in this example, I have a client which is nothing more than a console app. You're not going to have these package references that you need. But when you go to that dialog, let me go over here again, add connected service, and you add your first gRPC like proto document, it will go ahead and add those package references for you. So if you don't know what you need to do to get started, it's going to be super straightforward. Just go ahead and add that in. It'll bring in all the dependencies, and you'll have a strongly typed client available that you can just already consume.
Mm-hmm.
Okay, slightly snarky comment here, but I think it's a good question, is when you bring up add service reference and you see WCF there, and then there's how does this compare to WCF? Is this just the new shiny thing, or what's the big kind of differences between this and WCF?
Sarab, you want to take that?
So the easy part for me to answer is there is no WCF server on .NET Core 3. So if you're looking to move away from .NET remoting in WCF and you need some solution in .NET Core 3, this is probably what you would do.
And a reason for that is WCF is very Windows specific and built on Windows internal stuff, whereas gRPC is cross-platform, cross-everything, right?
Right. The joke I like to make is, we had this thing in Microsoft where we had the not invented here syndrome, where we wouldn't use anything if it wasn't built by us. I like to say we're the new Microsoft where we use the proudly found elsewhere. So we saw a very popular RPC framework. We saw people were using it in the community. So we're like, let's get behind where the community momentum is. Right. So there are functional differences. We're looking at what we can do if there's a migration path, and to that end, I think I don't know if you've covered this in one of your community links, John. I think Mark Rendell he started doing a blog post series on migrating from WCF to gRPC in .NET Core. And I think he's even done
I'll share that next week.
Okay, so that'll be something fun to share. Unfortunately, I don't have the best of answers for you. Like, there are things that we're still finding out, and I don't know. I don't think me personally can advocate for this app model switch already. I think it's case by case, and we'll improve the guidance as we go along. I think the link that John shared also did some compare and contrast with WCF, right?
Yeah.
Okay.
John, I actually sent the link to you, so if you can post it into Twitch and YouTube, that would be nice.
I think gRPC, it improves on WCF in some key ways. I've worked on a number of real world projects using WCF, and there are pain points with using it that I think gRPC has solved. So streaming is a lot easier, especially bidirectional streaming. There's obviously not enormous amounts of XML documentation to wire up your address, your binding, and your contract, your ABC and WCF. And with WCF, to generate a service proxy, you need your server running because it's generated at runtime, while gRPC, the generation happens from some proto files which are just checked into source control. So those proto files are your source of truth, rather than going through the hoops of creating a service contract, and then your messages, and then running your server, which generates WSDL, which then generates your service proxy. You can instead just generate the service proxy directly off the proto files.
All right, I think we should probably continue with the
right. So, and that's actually a good segue, because James alluded to the fact that you have a single proto file that's a source of truth. So if you actually see, I'm in my client project right now, and if you see the files that I've added, the location on disk for these are actually in the server project. I don't know if it's visible. I'll try and zoom in. But if you see, it's actually walking up a directory and it's in the server project, versus if I look at versus if I look at the server project, you'd see it should be right here. You see the difference? So yeah, it's like your protofiles, your source of truth. So I've gone ahead and added that, and let's do you want to jump in the client code, John, or you have something else?
Let's take a look at the client side.
Okay, so let me just quick, I've been showing the service, but I haven't actually spoken to what it does. So it's a pretty straightforward service. It is a client streaming service. So I have my service. It takes a stream of add requests. Add request is a simple message that just has a value, and it returns an add reply, which is just the sum of everything you stream to it. So let's go and look at the add a service real quick. It doesn't do anything fancy. Just request, it reads the current value from the request stream. When we reach the end of the request stream, it just replies with the sum. Let's go look at the client now. Okay.
So why are there two different kinds of clients?
Okay, so like we alluded to before, there was an existing gRPC implementation, and up until I'd say a couple of days ago, that was the only client implementation available on .NET. We have recently, if you guys been watching, Core Factory repo, we added HTTP2 support in HTTP client. That was one of the last stumbling blocks to enable a fully managed gRPC client. So what I have up here is what the old pattern looks like. There are a couple of things that we're still, trying to figure out what the shape of this API is. What is the analog to channel, which is a core concept in gRPC core, what the analog to that is in the managed implementation. So this API is subject to change, but it's still super straightforward to go ahead and use it. So, and the good thing is, and this is also applicable for people who already have stuff in .NET using gRPC core, there is a migration, there is a path to move to the .NET core implementation. As you can see, in this case, I can pretty much straightforward, I'm just gonna, the actual invocation of the client streaming call is just a streaming at async, and I'm passing it a client, which I'm switching. I'm gonna not use this for now. I'm gonna use the managed client version, and so there's nothing fancy going on here in terms of creating the client. It's just a new HTTP client with the base address, and then we have a static helper that hangs off of gRPC that will create you an adder client, right? And then I actually invoke this. So this example is pretty straightforward. All I'm doing is reading numbers from the console up until I get an empty line, which is the end, and then once I do that, I output the response I get from the server as to the console. So if I go ahead and run this, whoops, I'm just starting from the command line. There's no reason I particularly need to do that, but all right, server's running fine. And let's see, let's watch the logs. Okay, so client connected, so I can send a bunch of stuff. So I can send a bunch of, so this is client streaming. As I type these in and I hit return, these get sent over. And when I'm ready to finish, I get the sum back from the client.
So what I think we also want to demonstrate do a quick demo of the interceptors.
Okay, so what are interceptors, John? Like,
well, they are a gRPC concept. If you are familiar with ASP.NET Core concepts, it's very similar to middleware. So essentially, when you process a gRPC call, you can add these interceptors that will do pre-processing or post-processing on your request, or on your request on the way in, or on the response on the way out. We have gotten some community feedback asking that for interceptor support, because there's already a lot of libraries or other people have started using interceptor to solve cross-cutting concerns. For example, retries, or that would be a client one, but on the server side, interceptors can be used to handle timeouts, for example, for all of your calls, and make sure that none of your gRPC calls go over a certain time limit. So we have...
I'd like Jan to jump in if there's anything that you've seen or you've heard, because he's been part of the gRPC community way longer than any of us have.
Mm-hmm.
Yeah, to be honest, I was reading through the questions, so I wasn't really... Sorry.
What
was the question?
What have you seen as usage of interceptors in the gRPC community?
Well, so for authentication, also collecting stats,
logging, and those kind of things. Probably potentially error handling and those kind of concerns as well. I know this question will probably come up, which is if I'm using an ASP.NET, if I'm writing an ASP.NET Core app, what are when will I use, for example, an interceptor versus a middleware? Because the concepts are somewhat similar. The difference between interceptors and middlewares is that the middlewares will operate on the HTTP messages, and they will not have been deserialized. So all of your messages are raw messages. You have the access to all of the things on HTTP context, like headers and the raw byte stream. But if you want to operate on the actual gRPC messages, or the gRPC types, then you will have to do that inside the interceptor pipeline that we have. So if you want to operate on raw HTTP, then use middlewares. If you want to operate on gRPC messages, use interceptors.
Okay, so I'm going to show you folks an example. So John's written this max streaming request timeout interceptor. John, do you want to speak about what it does? And I'll go wire it up, and we can then show how it works, and then jump back into how it was written.
Sure. The concept here is that essentially if you have a client streaming interceptor, we want to make sure that the client stream isn't open for too long. So this interceptor will start a time. It will essentially cut off your calls after a certain time has elapsed. And you can configure that from inside the interceptor. And right now the default is 10 seconds. But I mean, for a demo, we probably would make it shorter. But yeah,
I should make it shorter.
Yeah, but I think after this demo, we should probably start wrapping up because
Okay, sure.
yeah.
So
this will be the last thing we demo.
So I got so wiring up interceptor is pretty straightforward. You know, we have the interceptors that hang off of gRPC service options, and I've gone ahead and added this, and this interceptor takes a time span. So if I go ahead and, whoops, sorry, let me go ahead and run this again. So in this example, so I have my app running, and now my client connects, and it pretty much terminates the client stream in 3 seconds. So if I can try and send some stuff, but if I go over that limit, and yeah, so my client stream got terminated. So if I try to do something else, I get a RPC exception. So you can see how people can use interceptors to enforce policy things. And John already alluded to like timeouts, deadlines, you know, things like that. And this is one of the pieces of like overwhelming feedback that we got because our initial prototype didn't have it, and we went to gRPC Conf and we saw everyone's like, now that's the one thing we have to have. We have libraries in our organization. We do policy-based enforcement using interceptors. So we've recently added support for that. That's something we're also looking for, feedback on the API.
Yeah, if there's any other gRPC features that are definitely needed, then give us that feedback and we'll try to add those in.
All right, so that's all we have for demos. We can.
There was another question that was brought up a little bit earlier on YouTube, and I'd like to address that, which is right now gRPC is using HTTP2, and we're demonstrating it essentially going over the network and stuff. Is there anything that we can do for in-process or cross-process, essentially not going over the network?
So the way our server stack is built is our transport is pluggable, right? And so for gRPC server implementations, like the other ones in the community, like the Netty-based one has a pluggable, I believe it has an in-memory transport. It also has like a Unix domain socket-based transport. So it is doable. We have not looked into it yet. There's definitely some like area of future investigation. The tricky bit for us would be our HTTP client stack does not support a pluggable transport. So we don't have a good answer there yet. We will look into it, but getting a pluggable transport on the client side is vaporware right now. It's a cool idea in our heads. We've done zero work towards achieving it.
All right. I think that is all the time we have. So I think this is probably a good point for us to finish.
Yeah, if you can switch back to the view, the camera view, and then for folks that want to kind of keep up, you mentioned several times wanting to have feedback and all that. Where's the best place for people to go for that? Is that just file an issue on the ASP.NET repos, or?
We actually have a repo under the gRPC.
gRPC, that's right. So, you mentioned that.
Yeah. So the actual link would be github.com/grpc/grpc-.net. That is where all of this work is currently being done. So if you file an issue there, we will see it and we will respond to it.
You can also find us all on Twitter, and me and James are around, and I can poke John if you ping me on Twitter, so we can get all your questions answered.
Very cool. All right, we'll have the link to that in the show notes. And thanks a bunch, everybody. Thanks for your time, and special shout out to Jan for staying up to very, very late for us in Munich. Much appreciated.
Thank you, Jan.
Thanks, folks. John, do you know how to end this stream?
Yeah.